I will show the code and also explain more about that. Okay, at first, I would like to explain about sequential model. As you know, a sequential model is a perfect model. Then you have one input as well as one output, and then your topological model is linear or plane. If you have these two options, you can just act for building your model by sequential model. But if you have multiple input as well as multiple output, you cannot, and it is better to don't use sequential model, and you have to prefer other models. When you have multiple input, multiple output, and also when you would like to shape your layer. What does mean share layer? For example, when you have some hidden layer and you would like to extract some feature from your hidden layers, that is mean share, right? Or you can, for example, share your a hidden layer in order to get one input. That is mean layer sharing. And when you have non-linear topological for your model, it is better to use other models like functional API, recurrent, and functional API with estimates. Okay, after running my model, I got this.
But one moment, Hussein, this is very interesting because when we train this autoencoder,
yeah,
we train the autoencoder in a sequential, and when we want to extract the code,
yeah,
we define the model. We use the model in the remember?
Not too much, but
no, because when we train there is a autoencoder. For example, it's 3 layers.
Yeah.
It's a hidden layer. First, it's one input layer, and we need to extract the code from the remember. So we define another model as a model. We define another model as using model ABR because we need to extract the output from the first layer, which is the code.
Yeah.
So we use one example sequential and model.
Yeah.
Because model is much easier, as you mentioned, to extract the output from in layer, for example. So, for example, if you are training a deep neural network and you want to plot the feature maps, so in this case, if we can define it as a model, it will be much easier, in fact, to decide which layer we want to plot the feature maps, and you can extract the output from this one.
Yeah. Okay.
So I fully agree with you.
Okay. At first, I would like to show you the output of sequential model. As you can see, the loss is decreasing, and also accuracy for train and as well as validation data has a fluctuation but is increasing. And the model can detect but not too much correct. Okay. Here, I would like to explain more about functional API. Functional API is also another model in the Keras library. When you have multiple input as well as multiple output. For example, it is true for my model because I have multiple input, and I would like to get multiple outputs for 4 layers. And it is good for our model. And also when you would like to share your layer, it is better to use the functional API preferred. And also when your topological model is non-linear. And the functional API is more flexible model. What does it mean? It means that when you would like to connect, for example, the first layer to the third layer or first layer to the fourth layer, and you have a lot of layers, it is better to use a functional API. And as you know, the majority of problems are realistic and follow their directed isolated graph. And you would like to, for example, connect the first node or first layer to the third layer, or first layer to the fourth layer, or to the second layer to the last layer. And it is better to use functional API. The output for a functional API is here you can see the loss for train and validation are going down, as well as the accuracy for train and validation data is going up. And after, for example, epoch number 15, there is a gap between train and validation data about accuracy, and you can see. And the detection is in the left side of picture, that is almost here. And this is the last one I would like to explain about is the functional API with stride. What does mean? All of explanation about the functional API is true for functional API with stride, but stride is an additional aspect of this model. What does it mean? For example, when you have a picture 8 times 8, and you have a filter with size 2 times 2. In order to get output from this input with this filter size, you can set your stride and how you can step over picture. That is mean stride, and you can change the stride. And the topological and structure of model is like you can see in the picture. Start with 256 neurons and reach to 4 neurons. They are for labels. I will show you on code. That means that top X, top Y, bottom X, bottom Y. Okay, and
that would be nice if you can show us also, I mean, the code.
Yes,
for the sequential model and the function.
Okay.
So we can use the reference.
I have both 3 of them, and the output is here. And in the following, I made a comparison about these 3 models, and I would like to show you. If this is the make comparison about the time. Sequential is the first time, the middle one is functional API, and the last one is functional API with the square. You can see the first number is 110.37 minutes. It's too much for sequential. And I would say that we use 128 batch and also 25 epochs, as well as
so all the structure is the same.
Yes,
all the structure is the same.
Yes, and 3 layers for all of them.
But for this plot, it's much better to make it bar plot, not this one, because it looks like time series or something. So this one will be like 1 column representing time here. You know the bar plot?
Oh, I know. I know. Okay.
So this one like this, so it will look
nice.
Okay.
This
is very good.
And as you can see, the functional API.
No stride here. You don't have stride here. Stride here is 1.
No, last one.
Huh?
Last one. Functional API with the stride.
But what is the stride here? It's the default, which is 1.
What do you mean?
Because we need
that is the sequential model I run for data, and the second one functional API.
You don't define the stride here.
No, in the last one I defined this.
And
the time is decreased too much because I use the stride.
Yeah, you know why? Because stride, I mean, when we're using stride, we will minimize the number of activations.
Yes.
We will minimize the number of calculations. When the step, because we are moving with a stride with step 1, for example, and if you will move with a step 2, so you will scan the image faster. Number of activations will be much less.
Correct.
So stride has a huge impact on calculations. So it's logic that when you increase the stride size here to 2 times 2, 2,
yeah,
right? It means maybe half the. I mean, you will reduce number of activations and number of calculations.
Yes.
So, but if you want to make valid calculations, because if you added stride here equal to, maybe you will get the same.
Yeah.
But because the model is the same.
The model is the same for 3 of them.
I mean, this conversion, it's valid. This one with this one is okay.
Yeah.
Because here you use the default stride, which is 1.
Yeah.
Here you use the default stride, which is 1.
Yes.
So now the comparison is okay because now you have the same. All parameters are fixed.
Yeah.
So now we really can see that from functional API, it's much better. It's much more quick than this one.
Yes.
But you cannot compare this with this one. Because the stride is
the data and the structure is the same.
But stride is 2. So this is valid if you want to mention, if you want to show people the impact of strides. When we increase the stride, for example, we have less time. I mean, we have less activation, number of activations, and number of calculations will be much less. Yes. So it's expected that the computational time here will be much less. So I'm just so this comparison between this one and this one, it's okay, because now we can see that with the same stride, this one is faster.
Yes, you mean that, for example, I can make a comparison between different strides in the last model, yes? And it is not possible to make a comparison between the middle one and the last one.
Yes, because if you want to show people the impact of the stride, I can, for example, go with sequential stride 1, 2, 3, 4, and they really see the difference in the impact of the stride on calculations and accuracy. So maybe this slide, it should be, this is the calculation time, this is accuracy, this is the loss.
I have in the following slide.
So for each model, right?
Yeah.
For each sequential model with different stride, because we will see the impact of stride, because the stride will have impact on accuracy, impact of loss, impact of calculation time. Mm-hmm. Correct? So, yes. So this one will be very, very good. So we need to study the impact of the stride. We will do it with a sequential. All parameters are fixed except stride. Stride here 1, 2, 3, 4, and we will see the impact. We will do the same for functional, correct? Okay. And after that, you can compare between two models, for example, sequential and functional, using the same stride. People will see it from the graph. So it's by conclusion, people will conclude it from the two graphs, and they will understand that this one is much faster than this one.
Yes.
So I mean, when you want to make valid comparison, we need to fix 4 other variables, right? Mm-hmm. But do you know why stride is? Because I just explain it quickly. When you have an image like this one, right? We have an image, and we have this kernel size. We have this kernel, correct? So when we apply this kernel here, for example, we call it one activation. So if it's 3 times 3. It's like a neural network. This one like a neural network, correct?
Yeah.
With 9 inputs.
You can choose.
Okay. Okay. So this one, this is my image, and this is my kernel size. This one, it's 3 times 3. If I want to plot it, it will be like this one, like a neural network effect, like one neuron with 9 inputs. So this one, it's omega 1, omega 2, until omega 9, for example, it will be like this one, omega 1, omega 2, and omega 9. So this one will be the first feature map.
Yes.
So usually we select, for example, imagine that we selected 32 feature maps. So we'll have 32 ones from this. Yes. Correct? So we will have another one. So it will be 1, 2, and until 32 feature maps. So how many parameters here? We have 9 parameters for each kernel. When it's 32 feature maps, it means we have 32 kernels with different parameters, different values, right? So we try. Mm-hmm.
Can you please adjust the camera? It's a blur.
Okay.
Yeah.
Is it more?
Zooming was enough, but it was, yeah, fine now. Thank you.
Yeah. So if we have a picture, for example, we have an image, and we need to scan this image, and we will define the kernel size. If the kernel size is 3 times 3, we will have 9 parameters.
Yes.
How many kernels we have? Number of kernels will be the number of feature maps which we need to extract. If you have 32 feature maps, so we will have 32 kernels with different sets of parameters. So the kernel will be like one neuron, in fact. It will be like this one neuron. So the first kernel will be 1 neuron, and it has 9 values connected to it. Correct?
Yes.
When we scan, each time we make some scanning, we make convolution. We multiply this value with the pixel value, correct? And we do those convolution, right? Correct? We do those convolutions. So each time, in fact, when we put this one, we will have one activation, and after that, we will move it one step, right? So the second time, we will, because if the stride size is, imagine it's 2.
Yes.
The stride size, so we will move 2 steps. So the second one will be like this one.
Yes.
Correct?
Exactly.
Exactly. So
one stride.
for 2, I'm selecting 2. Stride equal 2. We move the 2 steps, right? So and we will do another activation. So imagine when the stride size is increasing, what will happen? Number of activations will be less.
Yeah,
decrease. And when the number of activations is less, it means calculation time will be less, because we will scan the whole image, because we will go from left to right, correct, and from top to bottom. So we will scan the image faster. And we can calculate that. Imagine the image is 64 times 64, so we can calculate how many scans, how many activations. So when the stride size is increasing, number of activations will decreasing.
Yeah.
But when the number of is decreasing, so the impact will be on time, calculation time will be less. So now we can understand why the calculation time will be less when the stride is increasing. Imagine that the number of strides equals 3. Imagine number of strides will be 3. So in this case, the image will be like this one. If I have an image like this one, so I will just do like this one, 3, correct, without any overlap. Imagine. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, for example. If it's 3 times 27, if it is 27 pixels times 27 pixels, with the stride size equal to 3, and pixel size it's 3 times 3. So in this case, we will make 9 activations. But if you set stride equal to, so in this case, number of activations will increase, and time will increase. But just imagine how much overlap you want to make, right? The amount of overlap, it will impact maybe the accuracy of the feature maps which we take part extracting, correct? And it will impact the accuracy and loss.
Yes. Thank you.
And it will be maybe it's different from data set to another data set. I don't know how can, but it's very exciting. I mean, we've been discussing this idea, and it's very exciting because you can study the impact of the stride in calculation time and also the accuracy and loss.
Yeah.
So in fact, Hussein and Ahmed, they decided to change their project. They will not go to the end. They will not deliver a product, but they will focus on studying the impact of stride on calculation time, accuracy, and loss. It was their data set. So they are working with the same data set, but they will go into more academic direction, and they will try to study the impact of stride. He will study, Hussein, he will study what is the difference. He will compare between functional and sequential KPIs, and also he will study the impact of stride on the accuracy, loss, and calculation time. And I guess this is something very, very useful. But also, yeah.
Thank you for your explanation.
Yes, so I hope that it's.
Yeah, I got something good. Yeah.
So it's exciting, and I'm really looking forward to see because this study, it will be very, very good, and it will have some academic value. So it will be something published, in fact.
Yeah.
We are not just building a system for license plate simulation, for example, but we try to study the effect of stride on the calculation time, accuracy, and loss. Yeah. Which is very, very important. But to do this study, we need to fix all variables, right? Yeah. All variables must be fixed except strides. And you need to select a kernel size which will allow you, for example, if I selected the kernel size 3 times 3, I can just go for 1, 2, and 3, for example. But if you want to get more results, so we need to select maybe 7 times 7 kernel size, correct? Yeah. So in this case, we will have better freedom. I can test the stride equal 1, 2, 3, 4, 5, 6, 7, for example. When it's 7, it means there is no overlap, right? We are just taking like picture here and move this one and this one. So what will be the impact? It's something very, very important. So we need really to go through all those and explain it clearly in the publication, in the paper, for example. And it will be very, very useful because many people want to understand what will be the impact. Yes. I don't know, is there any other thing which should be considered here, for example? Maybe just fix all parameters, fix all hyperparameters. Yeah. All things must, because if I need to study the impact of stride, I need to make all other variables fixed, the structure and the hyperparameters of your model.
there is something in operation research about sensitive analysis, and maybe, for example, a stripe has a sensitive to other parameters, and it is better after, for example, extracting good feature from stripe and change some hyperparameter or parameter in order to find the correlation or interaction between different parameters with stripes. I think there is a correlation and connection between the stripe and batch size. We are doing for solving some example, and we think there is a connection and correlation between stripe and batch size.
Yeah, so it's fine. In this case, you will run a different experiment.
Yeah.
You will fix the stripe size, and you will change batch size. If you want to study sensitivity analysis, means I want to find if there is correlation between two variables. So I need to fix one, and it changes the other one, and you see if there is some changes, right?
Yeah.
So in this case, you need to for example, to select 4 or 5 values for batch size with fixed stripes, and the plot also computation time, loss, and accuracy.
Yeah.
So and try to see if there is some. You will generate a big table, and maybe from this table you can find some correlations. Or
yeah, that would be nice.
Yeah.
We are continue, and just for demonstrate the results, I would like to show the validation, accuracy, and loss. And as you can see, the validation is increasing, and also the loss is decreasing. About the training data is the same. The accuracy is going up, and the loss is going down. And after, for example, comparison, as you can see, the functional API has a better performance than the sequential, and also the functional API with the stripe is the best.
You know why? Did you figure out why?
Because of the at first decreasing the number of parameters, and as well as
number of parameters will be the same. Number of trainable parameters will be the same.
Number of parameters is not
in model API.
Yes.
So number of weights will be different.
Because in the functional API we are using max pooling, and we would like to be on some neurons, and then
so you are using max pooling in the model?
Yes, for functional API, yes, but for the functional API with the stripe, no.
So because we need, as I told you, I mean, your max pooling also. Max pooling, it's good for
overfitting and
yes,
avoiding overfitting.
But max pooling, it will reduce the size of the feature map. And if you use the max pooling in one model, you need to use the same in the other one, because when the feature map is small, number of activations will be smaller. So, and as I told you, if you want to study the impact, you need to fix all parameters. If you are using one layer for max pooling and model API, you need to use it in sequential API as well. Because max pooling, what will happen for max pooling? If I have an image of this size, I mean the size will be reduced to half, correct?
Yeah, I know, yeah.
It's half or quarter?
I think half.
Okay, so the size will be like this one. And then when the size is reducing, number of pixels is much less. So number of activations will be less. So if you are using max pooling and functional, what will happen? It will not impact, by the way, it will not impact number of parameters, but it will impact number of calculations. It will be faster.
Yeah.
So if you are using max pooling in model API, you must use it in sequential API as well. You need to keep the same structure, the same number of layers, Then if you are using max pooling in some between two layers, sublayers, it must be exactly the same as the other one. Because max pooling, it will reduce the feature map, and when the feature map is reduced, it will be the same effect here. I will scan this one faster because the size is less. Correct? Yes. It's like half page, it's like before page, and then if you divide it, if I want to scan it,
yes,
it will be the same. Number of activations will be less. And even number of activations, it's number of calculations.
Yeah. To be honest, this assignment or a project, in order to get a better result, at first we don't have any, for example, vision about make comparison.
No, but because I mean, we agreed that you will study the impact of the
time. But after our meeting, we decided, for example, to what you said and what you are thinking, and we have agreed.
But this comparison then will not be valid. Why? Because here I'm using max boolean here.
Yeah.
So if you are using max boolean here, at some point you will reduce number of activations, a number of activations, number of calculations. So this one will be faster because I use max boolean. Use the same structure here and the same structure here, and you make comparison. In this case, we can understand if there is a difference or not. Maybe this one is efficient, maybe this one is more efficient. We don't know.
Yes.
But number of parameters must be the same.
Yeah.
Right? Because if I have the same number of layers, I will have the same number of pictures, I will have the same number of weights. So number of parameters will not impact it at all. Even if you are using max boolean, it will not impact number of parameters. Right?
Yes.
We do max boolean because I want I need to reduce the size of the feature map. And in the fully connected layer, if you're using two fully connected layers, I need to select less number of units in the fully connected layer.
Yeah.
In general, we do this. We use max boolean for this, right? Because we need to just reduce the size of the feature maps. So in the first fully connected layer should not be very huge.
Yes.
Right?
Yes.
Because we will use flatten, and after flatten layer, you need to use fully connected layer. So if the size of the feature maps is very big, really, I mean the next layer should be comparable to it. Should be also a large number of neurons. So we use max boolean for this, right? So if you want to make comparison valid, I mean we cannot say now that this one is faster because you are using max boolean here. And when you are using max boolean here, it will impact the activation number of activations. So it's a logic. I mean, if you give it to someone who will be reviewing it, and will say, okay, both are different. Who are using max boolean here. So this is the reason that this one is faster.
Yes.
Make it exactly the same.
Yeah.
Make it exactly the same and run it, right? And we will see, is there any difference? Maybe there will be some difference in some milliseconds or something, right?
Yeah.
Maybe both will be the same. If both are the same in terms of time, there should be other advantage, right? You can get conclusion. I mean, in research, you don't try to prove the idea which you believe in, right? Because in this, I can squeeze it. You know, I can try to squeeze it and try to prove the point of view was correct, right? Maybe the research results will be different, and maybe it will give us to open the door for more opportunities and stuff like this. So please fix all parameters here, all layers, and be sure that number of parameters here is the same as the number of parameters here. Right? Okay. Even if you are using max boolean will not impact number of parameters except in the fully connected layer. But in this example, we don't need to change the fully connected layer. We will use the same. I mean, you have only one layer at the end, I guess, for four outputs.
Yeah.
For the bounding course, right? So just to repeat this one with fixing parameters, and I'm really excited to see if there will be a difference. Because if there is even little difference, this difference will be important, maybe for systems with huge data systems.
Okay, thank you. And at the end of the presentation, as I told already you, I would like to explain briefly about transfer learning. When you are building a model, there is a possibility in the Keras library to save your model, to save your features, to save your structure, to save your weights and everything. And you can use model.save in the Keras library in order to save your model. And if you would like to just save weights, you can use model.save underline weights. And then when you are trying to build a new model, you can import the load model class in the Keras library and import the model you already saved. And at the moment, you don't need to build your model at first. You can just compile your model with those weights and features already you found. And this is the feature in the transfer learning section of deep learning in the Keras library. I applied this for model, and I can show you on code.
This part is very, very important, in fact, because when you train a model, imagine that you spend 5 hours training your model, and you will get new data, for example, in the near future. You don't need to start from scratch each time. You just need to save your model weights, and after that you can upload. And instead of initializing it from by random values, you can initialize it with already those values and retrain the code one more time.
What is so important is that you have to apply the same topological model for the first and that one you would like to try.
Yeah, this is very important. So, for example, if you want to use this model, for example, I have been using this model for classifying images of the image size was 500 times 500. If you want to use the same model for another data set, you need to resize the new data set to have the same size as this one. This is scaling it downwards. So this is very, very important. Yes.
Yes.
Maybe you need to change share your screen. So
no, not this one.
Because we need to start from the beginning.
Okay, the section library is the same, and I would say that at first import the CSV file with 237 cards, and as we don't have enough cards, we would like to apply the data augmentation. You can use this structure or the explain about that image data generator, and there is some parameter. What do you call it?
No, I mean it's from Keras.preprocessing, right? So
yeah.
Yes. So in fact, it's an image data generator. It's from Keras preprocessing.
Yes.
Image. It's for data augmentation. And data augmentation is very important.
Yeah.
Can you talk about techniques that you usually use in data augmentation? How they increase the size?
Yes, I will explain.
So in fact, they can just make some rotations. So
yes, exactly. As you know, and everybody knows, there is, for example, a different flips, a different shapes, a different zoom size, brightness for every picture, and you can apply all of them for each picture here and find and get a new picture in order to augment your data set. For example, you can do rescaling, horizontal flip, rotation range, zoom range, and the last one is about the validation split, about 20, exactly 20%. You can use just one of them for your data augmentation section. It doesn't matter, and you can use, for example, all of them. And also there is other parameters here, and you can put in the parameters. After creating data generator means data gen.
But can you decide how much increase you want in your data set?
To be honest, I don't know exactly, but it's completely related to the batch size. Yes, for example, if you use and selected 128 batch size, in each iteration, model tries to build a batch of 128 images. And after creating data generator, you can create iterator for training data and for validating data. As we have a data frame, I already explained about that. You have to use flow from data frame. All of these are, and what's important here is the batch size. When you use much batch size, you would like to get more output.
More images.
Yes, images.
When the batch size increases.
Yes, increase, but the time will be
Much
decreased.
later.
Yes, will be decreased when you use
Smaller.
Yeah, smaller.
Smaller batch size.
Exactly. And what I tried for that was the row, as we have 4 labels in the output. It is better to run option in the class mode. I tried all of other class mode and I didn't get any good result. Maybe sometimes I got the error. It is better to use raw because you have multiple outputs in the output layer.
But the output will be the same. They will not change it, or they will add some.
For some of them, yes. For some of them, we got
different
yeah.
bounding nodes.
Yes. Yeah. And here is the my input layer as the functional API is the convolutional network. You have to at first put the size of image with the channels here. And after, for example, applying different layers at here, convolutional, you have to convert your images to the flatten as a vector in order to get your output as a 4 labels. It is very important to do flatten here.
What is this software?
Is the size of filter, and you can change it to, for example, like this, no matter. Is the same.
Okay, so I mean the code you understand when it's 3, it's not one-dimensional.
Yes. Yeah. Yes, you can. When you, for example, have
because it's convert 2D.
Yes, exactly. Yeah.
Okay.
And it's the same like this. You can.
Okay.
And in the following, I used the.
So here, for example, you didn't use any. You didn't use
stride. I used the stride.
If you use a stride equal
yes,
to
here.
padding the scene. Yes.
Yes.
But we didn't use max pooling.
No. When you use the stride, you.
So functional API, I mean, you can use it using this model API.
Yes. Yes. Just a different with the stride.
And in this case, the model will be, it will have the input layer
and the last
and the output layer. And it's the same. If you want to train, for example, if you want to train autoencoder, for example, and if you want to get the output, the code, right? So the input will be the input, and the layer you just need to define the layer which will give you specific layer which you want to get. So it will be the layer which will give you the code.
Yes,
the encoder. I call it encoder layer, for example.
Yeah, we already talked about, for example, flexible, being flexible. This model. This one of reasons we can call this model flexible. It is, for example, you can put your first layer or last layer here, and it is optional up to, and everything is up to you. And this 61 line in the number this line. We have a plot mode. In this line, you can, for example, save your structural model. For example, how many parameters you have, how many layers you have in each iteration. And this section is important, but there is a formula for this. This is means that in each iteration or epoch of our model, we have different steps. And this steps size string. And I mean, in each iteration, you have each epoch, you have different iterations. For maybe in each epoch, you have 10 iterations in order to get best result in each epoch. I can show you. And I use 25 epochs and optimize the Adam, the same. And here you can fit your model, and I would say that it is good for all of us to use the start and the end time for getting your time with this command.
So this one, it's important to know convolution.
Yes.
For that block.
Yeah. And here I use a plot history in order to make a plot and draw, and I put it in the another directory here in order to get nicer shape for our model. And here I call it, and I use the evaluation generator for finding validation loss and accuracy, as well as training loss and training accuracy, and I get a print all of them here, and then I import a test image in the last section in order to test for model. And I use the CV2 class in the CV2 library. And here I use transfer learning in order to save the structure, the features model, as well as the weights, as that one I already told in the last page of presentation. And I do a normalization and resize. And in this section, I predict.
When you save the model alone, it saves the model with weights or without weights?
The whole
model,
yes.
whole model.
Yes,
with weights.
Yes, and but the following one is just you can save the weights, and the size of the last one is much less than the first one, because in the last one you can just save the weights, but the first one you can save the features, you can save the parameters, you can save the whole topological of model. And as already we have 4 labels for each picture, top X, top Y, bottom X, bottom Y. We have 4 labels output here. We can save it as XT, YT, XB, YD, and then we can do a conversion here in order to convert BGR to the RGB.
It's top bottom, so it's coordinates of
yes.
bounding box.
You explain about that previous session. Yes. And here is the formula in the CV2 class in the cross library CV2 library in order to predict, and I can run it.
But you will train.
Yeah, I can run it, but maybe 2 or 3 minutes takes.
But if you, I mean, it's fine, no problem, you can run it. Okay. But it will be nice in this case, for example, to use a trained model. You can have another subroutine, for example.
Maybe you can just load
all trained.
You can skip the whole thing.
I don't know if it's possible by the PyCharm or not.
Yeah, it is possible.
What is that?
And load weights, yes.
Train the model.
Skip the train. Just load model.
So now because you trained a model and it's already saved here.
Yes.
Right? So you can upload this model.
Yes. Oh, yeah. Okay. Oh.
But as I told you, if you want your comparison to be valid, you must use exactly the same structure, the same layers.
I would say that I completely agree with you, but we had a aim, for example, to find a detection at first. We don't, for example, we didn't have any aim or goal in order to make comparison. Yes.
No.
These days we would like to do that comparison.
That we will make those comparisons.
Yeah, I know.
Right? Because we need to study the effect of the stride size on computational time, accuracy, and stuff like this. And also we need to make comparison between functional ABI and sequential ABI. Is there any difference?
Yeah.
But if you said there is difference in number of numbers, you cannot say this at all, because both should be the same exactly, no difference.
Yeah.
Maybe the difference, maybe one model is much easier, so there are some advantage and disadvantage. Easy to use, for example. But when I train, for example, the autoencoder, I use both. I train the autoencoder as a sequential because it's easy for me to just do it. Because sequential is really easy, just adding layers. But when I try to extract the encoder, because I want an encoder. After training the autoencoder, I'm interested in the encoder because I want to encode the image into a code, right? So this is a part which I'm interested in. So I just extracted it using a model ABI. So the input will be the same input layer as you did here, and the output will be the last layer of the input.
Yeah.
It's really nice.
So the only difference is that we can access the intermediate layers. The
Yeah,
output
yeah, yeah.
will be the same.
Yeah, yeah,
Should be.
exactly the same, no difference at all. But if you want to get access to intermediate layers, it will be easy using model. But as I told you, it's exciting because what we are doing is important. We need to know, is there any difference or not? We need to check really computation time. Is there any difference in computation time?
About these three models, yes.
Yeah, yeah. But no, because now we discovered that you use the max volume in one model.
Yeah, yeah.
Both should be the same.
Yeah.
You need to run it one more time. In training, maybe also in testing.
Yeah.
Maybe one is because it's sequential, maybe it's much faster. I don't know. I mean, you need to run the computation time in maybe training and also testing.
Yeah.
Maybe one is faster. You know, if it is faster by millisecond, it will be fantastic. Because in this case, if you are using it in an autonomous car, we can just recommend people to use this one. Because 1 millisecond is very, very important. 1 millisecond in driving, when you are driving autonomous car at speed of 100 kilometers per hour, for example, 1 millisecond, it means maybe 20 meters or 50 meters on road, right? So when you act faster, it will be very, very efficient. So this is very important.
Yeah.
So compare, you need to try to find this time for not only for training, it's for training, and most importantly also from my point of view for testing when we implement it in real life, right?
Yeah.
So, okay.
I would like to show you about that iteration in each epoch, and it is better to run it.
Okay.
Yeah. Yeah, you can see here the number of parameters
Yes.
and
1 million?
yes, as you can see, at the moment we are in the first epoch, and each epoch has a different iteration. Yes, for example, the first one, and you can see the estimate time are here, and this is the second iteration in the first epoch. This is exactly the meaning of step size. I already explained about that.
Because it's
when
dynamic.
yes, when you increase the batch size, the iteration will be decreased. And when you decrease your batch size, the number of iteration will be increased.
But why time is different from one epoch to another epoch? Why one epoch takes more time than the rest?
Maybe because of
Because of
the batch size, I think.
But the batch size is constant.
Yes, because the model, in addition to solving the and in order to building the model, model is augmenting data for the following section. At the moment, model.
So data augmentation is
yes.
included in the training phase.
Exactly. Yes. Yes. I just would like to show you the iteration here and the difference between the functional API and the sequential. And in each iteration, you can find that there is two important actions: one for data augmentation and another for learning from our data.
Yes. Can I ask you a question? If we have one image and this image has two objects, and we will have two bounding blocks. Some images will have one bounding box. One image will have two bounding blocks. So how can you solve it?
You mean?
So now the image maybe
we don't have, for example, 4 points. You have to.
No, you have 2 points, correct? Or 4 points. I mean, we have four coordinates, correct?
Yeah.
We have max mean x, max mean y, correct? So it's 4 points. So if you have 2 objects in the image, which we need to detect, if you have 2 cars in the image, and we just try to count number of cars in each image. So how can we do this?
You can use region-based. Region-based, where you have several regions.
But bounding boxes?
No, when you go to your image, you actually have kind of several images, kind of cutting out several images. So then you can get several bounding boxes. boxes.
Mhm.
So you do a cluster.
Oh, so we divide the image into sub-images or something?
Yes.
Mhm.
It's the same way they are used in this mosque.
Or must or say, so they use the same technique.
Yeah, it's region.
Okay. Mhm. I want to understand this mechanism. Because I mean, in some images, for example, Alex, they try to detect several objects in the same image. Sometimes it has one object, some images has 5, 6 images, right? So it's not the same one. So I really wish to know how. So in RCNN, they use this mechanism.
They use it in YOLO.
In YOLO also.
YOLO, they use BG based.
So if someone of you can try to dig for this one and explain it in some slides, because it's some practically there are many images which has several objects in the image. You need to detect how many objects, detecting multiple cars, multiple animals. I have a data set, for example, for Enro, and some images they have two animals in the same image. So we need to have one bounding box for each image. So is there any way to deal with this if you are not using RCNN? Because if you want to just use VGG scheme, for example, or something. So how can we do this?
VGG is the type of using the learned data already.
Yeah, it's a training. For Alex in it, for example. So Muhammad, he was using a VGG scheme last time. So I will share this data set with him for so I will see. I will share it also with more people so they can try with it. Okay. It's Kangaroo data set, and it's images, the collected images, and each image, some images has only one animal and the other object, but we try to predict how many animals in each image.
Yeah, I got your question.
So if you have two, you have three, for example. So it's important because Vivian, do you have Vivian with us? Because Vivian also is working with the data set. And in some images also we will need to count how many objects. I will not mention it because he's working with a company and maybe it's but he has images and each image has number of objects and we want to count how many objects in each image because sometimes some objects will come together. There will be some overlap, right? And we need to count how many items, how many objects in each image. We count. I mean the task here is to count. Right? So, for example, scanning a process in a company or something, you need to count how many images on the computer play. So, okay, yes. So, any questions to Hussein while his program is running? We are in book 21. Any questions from people online? Can you hear us online? Are you taking a breakfast? Maybe.
Yes, we can hear you. No question.
Okay.
Thank you.
Because just last week, the people are talking online teaching, and I saw one picture. I mean, she is, mother. She published a picture for her son who was sleeping in a couch, and the iPad was just running, and he was just. I feel this in all my online teaching. In fact, people, I ask question. People, please react. So.
No. We are attending your lecture very attentively.
Okay, thanks, Hamad. Do you have any questions to Hussein?
No, thank you.
Okay. Now he is close to finish because he has some concluding remarks. We have also, we have one student who is working in cancer data set. I don't know if he is online or not. Jubair? Cancer. Jubair? Muhammad? So because some people, they didn't present last time. So if they are able to present it today, it will be very, very good. So is there any development in other projects? For example, if someone wants to say something today, is there anything, Pure Now, for example, or project?
No, not
Okay. Yes.
Okay,
Hmm.
this is the plus.
But also it will be nice, Hussein, if you can make using a model, try to make different structures, connect layers, and they have some feedbacks.
Yeah.
It will be nice if you can make an example and they yes. If you can make it, for example, and they show it to us next week, it will be very good to show very complex structures. How can we make it easily using model API? It will be very useful.
For the next week, because I have 2 or 3 projects my supervisor, I have to do it for next week. I don't think so. And
The
for
week
the
after.
that week,
Okay.
I can do it.
Mhm.
And the accuracy in the last model you can see here. And the training time is 7.
Mhm.
There you can see the number of epochs. And this is the prediction.
Mhm.
And you can see the validation loss and validation accuracy here.
Mhm.
And training loss and training accuracy.
Okay.
That's
Okay. So thank you very much, Hussein. Ahmed, do you want to say something, because it's also your project? Ahmed.
Yeah,
Do you-
hi. No.
Okay.
No, I think Hussein did a great job. So I think I totally agree with him about what he's saying.
Okay, but we need to fix all parameters. If you need to really to make good comparison, just to fix all parameters, fix the structure.
Yeah.
You need to be sure that all number of weights is the same in all models, and after that you need to run it and make good comparison, because this comparison will be fantastic, because it will help us to understand the difference between model and sequential APIs. So please, I mean, try to fix and because we need to study the effect of changing stride size, for example, on computational time, accuracy, and so on. Overlap is very important. We didn't study it. I mean, will it make difference if we will use? Yeah.
I want to ask a question. What is the main usage of 1 times 1 kernel or filter in the convolutional rate?
Oh, 1 dimension?
Yeah, 1 times 1.
1 times 1?
Yeah, you see it in some networks. They use filter kernel size 1 times 1.
So what will be the value? Because convolution, it will not make any convolution, right?
Yeah, that's why I don't understand.
Can you share an example, for example? If you have an
Yeah.
example? Yes, because is that an example which is running and all layers have the same kernel size?
Different kernel sizes in the network, but they
In one layer they used 1 times 1?
Yeah.
So maybe just transferring it to the next layer, just transferring, correct?
Yeah.
It's exciting also, we can try it, right? We can use it even with endless, for example.
Yeah.
We can just 1 layer, we can convert 1 layer into kernel size will be 1 times 1, and we can test it.
It's just hard to understand what
Hmm?
the use of it is, as you say, it's convolution.
Yeah, maybe they just maybe if he's using some feedbacks or something, you want to transfer from 1 layer to another layer without doing anything, because
Sample and find it.
if you can find an example, it would be very good. But when it's 1 times 1, it will not do any convolutions, right?
That's what I'm struggling
Yeah.
to understand. Why they use it.
Maybe you want to use another look. Maybe you just try to expand and use more max pooling. So I can use 1 max pooling here, and I will just have a layer which will do nothing, but it will transfer this one to, and I will do another max pooling. If you want to use.
Are you talking about 1 by 1? Because I was reading about multi-objects. In one image, they use this grid, these varieties of grids, 1 by 1, and they calculate the probability of that grid containing the object or not. Then they combine the grids and they find multiple objects within the image.
Yeah, can you share it with, can you share screen, for example? It's 1 by 1.
They turn the image into little grids, then they calculate the probability of each grid containing a specific object. and then combine the grids which
Oh, but that's
contain the similar objects. So at the end, we found 3 objects.
okay. But what is the size of S?
So this,
Mhm.
we have to extract it
Mhm.
using the convention method.
Mhm. So what is the size here, which is 1 times 1?
I think that in the end, it's 1 times 1.
But no, I mean here, is it possible? Because when we divide it into grids, each grid is an image, right?
Yes, yes, yes.
So and you will apply maybe kernel size to all of those.
Yes,
right?
it's all of those. Yes.
And we find
It's like a
similarity.
filter, yes.
Yes. You try, I guess, to find similarity. So all green areas will be located, or background. So this one will be, you know, this spread area, all this spread area will be background. Will be, but the kernel size, because it is reduction layer followed by sequence convolution layer. Okay. Inception models. You can share this one with me. Can read it.
And also, I want to know to say in the previous session you told that it is possible to convert the image to text, and we made a function for that, but I didn't use
Image
it.
into
Yes.
text.
Yes, I can show you over the image to the text. We made a function in this tab, and but we didn't use for this model, and we can use it. I think it works, but I can show you in that session. I will not explain about that complicated model in the future.
Okay.
But we made this function for the converting image to the text.
Text.
And
The text is a description of the image.
Yes.
Okay.
You can,
So it's captioning.
but it is very for that in this section I can use custom config, and we have to find a lot of config for different numbers and alphabets, and put all of them here in order to get a good result.
Yeah, so but
yes.
you need to have a data set label
Yes.
the data set.
For example, Russian config, English config, Iranian config, Arabic config. Every country, it is better to find their alphabet and put here as a config if it is available on internet, and get a realistic data about the number is available on the plate now. Yeah, I already find the number of here, but they are not enough. I think about 100 would be better than the current one. It is about the config of each prediction.
Yeah. So if you, but just to share this one with me, Amir, this 1 times 1. He showed me an example here. In fact, there is an image. So they divide this image into grids, and we find similarity between each cell. And the cell size will be S times S. So it's a try to identify the background from object, for example. We need to classify it's like segmentation.
First we use one by one grid, then we expand it.
So it's like transferring it also, because I will divide the image into grids, and each grid will be an image. So I need to keep it as is it, because I will transfer it to another part, which will do some processing. So just for transferring or slicing the image into subsections, and each section I will try to find similarity between each image 7. So I can say, okay, this is background, this one also background, this one similar to this one. So all this is a background. It's like for image segmentation.
So you will define the
Yes.
mandate.
But you just share it with me. Check it. Okay, so I guess we don't have any questions online, so we will take maybe 10 minutes break, and after that we will start at we can start at, for example, 10 or. Okay, so just please, I mean, try to get coffee and yeah.